In this problem, a student is trying to make a planter shade out of 24 square feet of cardboard. This planter shade will have no right side and no bottom. It will be sitting on the ground directly on top of our plants. Therefore, it will have no bottom. The bottom will just be the ground, and the right side will be open to the air. Therefore, this planter shade has a front, a back, a left side, and a top. We might note that the front and back are both squares, while the left and top are rectangles. The front and back are symbolized by this square labeled X on the side and the bottom, and the left and top both have a length of L and a height of X. Therefore, we can say that for our front, we'll have a square. For our back, we'll have a square also. For the left, we'll have a rectangle. And for the top, we'll also have a rectangle. Now, we'll try to write an equation for the surface area of the shade. We'll start on the front side. The front side is a square, and that square will have an area of the side length squared. The back side will be identical. Now, the side length of that square we've just called x. We don't know how big that is, but we can replace that L with x. The back will be the same. It will be another x by x square. That's symbolized by this smaller square on the back side of the planter. On the left side, we have a rectangle. Because of the perspective of a drawing, it looks a little bit diagonal, but you may notice that it has an L and an X, which I've circled in orange. Now, the area of a rectangle is length times width. We've represented the length with the letter L, but we've represented the width not with W, but an X in this picture. Therefore, we'll say the left side has an area of L times X. Now, let's get the area on the top side. The top side is another rectangle, which I'm going to outline in blue now. Now, this rectangle still has a length of L, and its width will be the same as X. Because the bottom of our square was X, the top of our square must also be X. And so the width of this rectangle is represented by X, while the length is still L. So, since we have another rectangle, we'll say that the top side's area is again L times X. Now we combine all of these terms. X squared plus X squared would give us 2x squared, and then Lx times Lx will equal 2 times x times L. This will be our surface area for this shape. Next, for part B, we are asked to find the length of the box in terms of x. We're going to use our area equation and the fact that the question told us that we have 24 square feet of material to use. Therefore, we will let area equal 24. We replace the letter A in the equation we wrote in the previous step by the number 24. We'll say 24 is equal to 2x squared plus 2xl. Now we're going to solve for L in order to try to write L in terms of x. This means we're going to have to subtract that 2x squared. We'll have 24 minus 2x squared is equal to 2xl. Then we will divide all of the terms by 2x to get L by itself. When we make that division, we'll have L equals 24 over 2x is 12 over x, and then 2x squared over 2x will give us negative x. Therefore, we can say L is 12 over x minus x. For part C, we are asked to write an equation for volume in terms of x. Note that this shape, even though it's open on the bottom and the right, is still a rectangular prism. A rectangular prism has a volume of length times width times height. We have an equation for length already. L is equal to 12 over x minus x. Therefore, we can replace the L in this equation by 12 over x minus x. We'll start by saying v equals parentheses 12 over x minus x. We'll multiply this by the width of this shape. However, the width of this shape is x. And the height of this shape is also x. Therefore, we'll say the volume is 12 over x minus x times another x. We can simplify this by multiplying the two x's on the outside of the parentheses together, and we'll say volume is equal to x squared times 12 over x minus x. We'll now multiply that x squared times 12 over x and times negative x. If we multiply x squared times 12 over x, we'll end up with 12x. The x on the bottom and one of the x's on the outside will cancel. And x squared times negative x will give us negative x to the third. And so this is our equation for volume, 12x minus x to the third. Part D asks, if the volume of the box is 16 square feet, find the values of x and L. We'll use the remainder theorem for this. We'll let the volume of the box be 16 square feet, and so we replace the v with 16. Therefore, our equation will be 16 equals 12x minus x to the third. Now to simplify, we will move the 12x over to the left and change its sign to negative. We'll also move the negative x to the third over to the left and change its sign to positive. Therefore, our equation will now be x to the third minus 12x plus 16 equals 0. Now let's think about all of the possible rational solutions to this polynomial. We're going to have to take all the factors of the constant divided by all the factors of the highest power coefficient. Our constant is 16. Now, let's think of all the numbers that can divide into 16 evenly. 1 certainly could. Since 16 is even, 2 could. 4 also could. And 8 could as well. And of course, it's divisible by itself, that's 16. The leading coefficient on x to the third is only 1, and the only thing that divides 1 evenly is 1 itself. Therefore, our possible rational solutions will be 1, 2, 4, 8, and 16. Using the remainder theorem, we can test all of these. Now let's try our possible x's, and we'll begin with x equals 1. Notice that I didn't list any negative numbers because we cannot have any negative distance in a real-world problem. If we plug 1 in everywhere we see x, we'll end up with 1 to the third power minus 12 times 1 plus 16. If we do the math, we'll end up with 5, and since this is not equal to 0, that means that x equals 1 is not a solution. We can eliminate it from consideration. Let's try 2 next. If we throw 2 in, we'll say 2 to the third minus 12 times 2 plus 16. If we do the math here, we'll end up with 2 to the third, which is 8, minus 12 times 2, which is minus 24, and then plus 16. But 16 plus 8 minus 24 does give 0. That is a correct solution, and therefore 2 will be our solution to this polynomial. So now that we know that our x is 2, we can also find our length. Again, since 2 is our solution, we'll let x equal 2, and we'll say length is 12 over x minus x. Since our x is 2, we'll say 12 over 2 minus 2, in that we've replaced all of these x's with 2. 12 over 2 gives 6, and if we subtract 2, we'll get 4. This means that if we have 24 square feet of cardboard and our volume is 16, this means our width, x, that means that our width must be 2 feet and our length must be 4 feet. And so this is how we find the dimensions that give us our target volume of 16 square feet. Thank you for watching. We'll see you again soon.